Assalamualaikum warahmatullahi wabarakatuh. My name is FATIN binti SHAHARIN and my matric number is S58539. In this presentation, I will explain about background, measurement, and analysis. Background about BFS and Kruskal'S. Background of this project. The main purpose of this project is to find the shortest way between two intersections on a road map can be described as a specific example of the shortest path issue in graphs, where the vertices correspond to intersection and the edges to road segments, each of which is weighted by the segment length. The algorithm that are used, breadth first search, BFS, and Kruskal'S algorithm.
Okay, my name Muhammad Aidel bin Muhammad Noor S59050. Okay, so we continue for the first algorithm, breadth first search BFS. Okay, so let's continue. Okay, so for measurement of BFS, okay, so BFS is measured to find the shorter path vertices from search and to measure the minimum distance between vertices and search. The way to measure the shorter path and minimum distance. Okay, so for the first, we initialize the queue for the unvisited nodes, and then for the second, we pick a node and add it to the queue, and then for the third, take the first node from the of the queue and add it to the list of visited nodes, and then we add all adjacent nodes of the just visited node to the queue only if they have not already been visited. And then we keep repeating step 4 and 5, we need to repeating step 3 and 4 until the queue is empty. Okay, next for analysis of BFS. Okay, so for BFS, we can calculate or assign the shorter path and minimum distance manually, so we can know if the path is correct or not. Okay, so this is for the queue of the path. Okay, so first, step 1. Step 1, we select 0 and insert into queue. And then for step 2, we visit neighbor of 0 and 1, 0, 1 and 3 and insert into the queue, and then delete 0 from queue and add to visited. And then for step 3, we visit neighbor of 1, 5 and 2, and then we insert into the queue and then delete 1 from the queue and add 2 visited. And next for step 4, we visit neighbor of 3, vertex 4 and insert into the queue and then delete 3 from the queue and add 2 visited. And next for step 5, we visit neighbor of 5, nonce and delete 5 from the queue and add 2 visited. And then for step 6, we visit neighbor of 2, 6 and 7 and insert into the queue and then delete 2 from the queue and add 2 visited. And then for step 7, we visit neighbor of 4, nonce and delete 4 from the queue and add 2 visited. And then for step 8, we visit neighbor of 6, nonce and delete 6 from the queue and add to the visited. And then for the last step 9, we visit neighbor of 7, nonce and we delete 5 we delete 7 from the queue and add 2 visited.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FAKHRUL bin AHMAD SEBRI with number matric 59583. Now I will present about the result calculate breadth first search manually. As we can see from this graph, we draw the graph of breadth first search start from vertex 0. So this breadth-first search will traverse to all the vertex made in order 0 to 1, 3, 5, 2, 4, 6, and 7. So these all the vertex visit. And the shortest path as we can calculate from the vertex 0 to 6 is 0, 1, 1 to 2, 2 to 6. So from 0 to 6, we traverse 3 edges. So the cost is 3 edges. Now I will present the algorithm using Java. As you can see, this is the constructor for this BFS, and this is the function to add edges into the Java, and this is the function to find the shortest path from BFS, and this function is for display the all visited vertex. Now this is the main function. Now I will input the data of vertex following this graph. Alright. So for this graph, we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 vertices, and edges is 1, 2, 3, 4, 5, 6, 7, 8. 8 edges. For the vertices, for the edges one, we will input this 0 to 1. 0 to 1, and so on. We will input to draw all the graph into the Java. So this input will ask for the start the output for breakfast stage. For now, I will input the 0. We follow the in this graph. So we can see the visited breakfast stage is 0, 1, 2, 3, 4, 5, 6, and 7. And for the find the shortest path, we input from the start from vertex 0 and ended with vertex 6. So we can see the shortest path from vertex 0 to 6 is 6, 2, 1, and 0. 6, 2, 1, and 0. And the cost for path is 3 edges. Okay, that's all from me. Thank you.
Measurement Kruskal'S algorithm. Kruskal'S algorithm is measured to find the cheapest edge. In Kruskal'S algorithm, the cheapest edge was calculated and the time complexity. The time complexity of Kruskal'S algorithm is 0 E log E, 0 V log V, where E is the node of edges and V is the number of vertices. Below is the steps to implement Kruskal'S algorithm. First, sort L of the edges from lightweight to heavyweight. Second, add the edge with the minimum weight to the spanning tree now. If the edge being added from a cycle, it should be rejected. Third, add edges until all vertices have been visited and a minimum spanning tree has been formed. Analysis. For the Kruskal'S, we can calculate or assign the minimum weight manually, so we can know if the part is correct or not. Below is a weighted graph before sort the edge. So as you can see, this is a diagram. we have 1, 2, 3, 4, 5, 5 vertices, and 1, 2, 3, 4, 5, 6, 7 edges. Okay, below is the table weight of the edges of the above graph. Edges 0, 1, 1, 2, 1, 3, 1, 4, 0, 2, 2, 3, 3, 4. And weight 1, 7, 10, 5, 3, 4, and 2. On the next slide. The next slide is we need to assort the edges in ascending order based on their weight. So as you can see here, edges 0, 1, 3, 4, 0, 2, 2, 3, 1, 4, 1, 2, 1, 3. And the weight is from the minimum to the maximum 1, 2, 3, 4, 5, 7, and 10.
Assalamualaikum warahmatullahi wabarakatuh, and a very good morning to Dr. Waheed. My name is AQILAH BINTI MOHAMMAD with registration number S59280. Now I would like to explain how to calculate the Kruskal'S. They have two ways to calculate the Kruskal'S. We have manually and by using the algorithm. So how we want to know that our calculation is correct, okay? When you're using the manual calculation or algorithm calculation, you can get the same output of minimum cost spending. So for my calculation, I will base on the table of the week that we sort already by ascending order. So first step is we need to add the age 01 with week 1, okay? With week 1 here. Okay, show you guys here. And then the second one is at the age 3, 4 with week 2. Also. And then the third one is at the age 0, 2. So here. This one. Okay. And then the fourth one is at the age 2, 3. Here. Okay. So we add each. Oh, sorry, it's okay. And then the number 5 is we need to add the age 1 for week to week 5. But in this part, we don't do it because it will start the cycle. Also for 6 and 7, we also don't do it because it will start the cycle. So now we can start to calculate the minimum cost spending. So by sum the week of the edges, which is 1, 2, 3, 4. Here, show you guys. 1, 2, 3, and 4. Okay, by add or sum of this week 1, 2, 3, and 4. And here will be the answer for the minimum cost spending is equal to 10. This is how we calculate manually. Next, I will explain how we using the algorithm. I will show. When we're using algorithm, we will get the same output here. Okay. Okay, so now I will show how to calculate the Kruskal'S by using the algorithm, and I will prove it that we will get the same minimum cost spending like the way we calculate manually. So first we need to enter number of vertices. So number vertices we have 5. Okay, and then we need to enter the number of edges. Number of edges is 7. Right. So for the value for each 0, we have 0, 1, 0, 1, and the weight is 1. Okay, and then for value for each 1 is 1, 2, and then the weight is 7. Okay, for the value for each array 2, we have 1, 3, week 7. Week 10, and then for each 3 we have 1, 4, with week 5. And then for number 4 is 1 4, and then 0 2 with the week 3. And then for each 5 we have 2 3 with week 4, and then the last one is value for each array 6 is 3 4 with week 2. Yes, the minimum cost spanning tree is total 10. Seems like we calculate manually. So this one is proof that the algorithm is correct. In a conclusion on this project for BFS and Kruskal's is BFS has a lot of benefit that make it a good choice. The second one, calculating the shortest path is one of the numerous applications of the BFS algorithm. And then the third one, to use it for improved performance, user must understand first the requirement and the data pattern. For the Kruskal's algorithm, it can be used to discover the shortest path between 2 points on a graph. The second one, the result of the program are similar to tasks received when conducting a manual calculating without the use of computer program. So this means here, even we use the manual calculating to calculate the Kruskal's, we still get the same output using the algorithm. And then the last one, Kruskal's algorithm is more time efficient.